So it happens. And let us open them and have a look at what happens. So let us discuss the problems one by one. And let me, as always, first ask you, who did it? Correctly or wrongly or whatever, who would like to discuss number one?
I have tried it. Don't,
Yes.
don't know, but
Okay.
but at least this problem actually was good because I could understand what I need to do,
Mhm.
and it was a positive start for me.
Okay.
Maybe
So
I can.
you can. Can you share
Okay.
your, yes, your screen?
Host needs
Just a
to.
second. I know. Let me
Okay.
find you where you are.
I am Gauri.
Yes, but where are you here? Now I will invite you as a co-host. Now you should be able, yes.
Okay. I'm trying to locate my screen, and it's done from my side, I think. Yeah. Can you see?
Now we can.
Okay, great. Is it visible though?
Make it larger.
Mm, okay. Like,
Just zoom in.
is it now doing or
It's always a bit slow. Let's wait. Make it full.
I'm
Yes.
I tried. Is it now better?
No, I only see the frame around. Just go to the. You see there the zoom 100% in a command line, so to say. Try to go there.
Comment line.
Yes, if you go above the text.
Okay, 100%. Okay.
Yes, put
200.
200. Yes.
Eh,
Okay, this is what were you doing?
so we have in the problem it gives us probability function,
Hmm.
probability density, which there is an equation with the x raised to delta.
Hmm.
And so first we need to get the free energy from this equation. How to get this? If free energy is equal to minus Ts.
Hmm.
The S can be substituted with the number of configurations, and
Hmm.
number of configuration is related to our probability, as learned in lectures.
Correct.
So we get this equation. There is a constant, but it's okay, and uh, we just solve this, and we get the final equation is like this. There are some constants like these, and x raised to delta.
Hmm.
And with respect to now x, if you differentiate, then we get force,
Hmm.
and the force is now these. So the x raised to delta minus 1 is the power now.
Yes.
And according to second equation, we already have another equation of force, which is related to our Flory exponent.
Hmm.
And I just equated them, and I got the relation between the delta and the Flory exponent.
Correct, because they have to go to both to give the same functional dependence
Okay.
on x.
So far I have reached to this step, and that's I
This is exactly what was required. So it's really great.
okay then.
Mhm.
Is there anybody who wants to ask any question or something? And I considered the prefactors as unity because there was proportionality sign. So at first I was confused, but then I think prefactors as unity is okay.
It's always the following. Look, all the dimensional prefactors would be the same because if you look at the force, yes, the only possible prefactor there is KBT divided by some length, some characteristic length.
Okay.
And this length is essentially a kind of a flory. So it's only about number prefactors, which you will never get by such considerations.
Okay. Okay, then maybe I can stop my share screen.
Yes, and let's ask other participants, are there any questions? Should we discuss this exercise more? I don't see any hands. I don't see anything in chat. So let's go on. Now we go to number 2. And essentially number 2 and number 3 are two variants of practically the same or very, very closely related problems. Now, the first one is self-avoiding chain analogon of a problem we solved exactly for a simple random walk chain. It's a random walk chain in a pore. So therefore, it's interesting to have a look what happens here with a self-avoiding chain. Now, a traditional question is, who did it? Did anybody do the exercise?
I did.
Yes. And now I have to know who you are.
Sorry, I don't know where did I write it, but yes, I have it.
Tell me who you are. I have to choose. Yes, to choose your.
Yeah, I know. Sorry, like Chisong Hu, but I need to use another counts as before. So just give a second. I will use new counts to join this meeting.
Okay, join it, and then you will get the.
Yes.
The rights. Okay, now there is somebody new. And
yeah, this one.
And now switch off the sound in one of the, yes. Now you are co-host.
Okay. Oh, shit. Let me like. How about now? Is any echoes?
Okay.
Okay, now it's okay. Sorry, wait a minute. Sure. Screen.
Okay.
Okay, let's go to this side. Because in problem 2, it says polymer in the pole, so we can consider like this. It's a cube pole, and the side length is L. So the total volume of this form is equal to L.
Okay.
Yeah, and it says the polymer molecule with n segments is squeezed in there, so it's like a lot of the polymer blobs inside the cubes. So there is another thing like the segments. It means segments in polymer, and the small n means number of the blobs, and n means number of the segments in each blobs. So we can get this thing to n. This is the first equation we later are going to use. And there is another saying that the total volume of the blobs is equal to the volume of this whole pole. So we can know the volume of pole is like this one. So the pole is equal to the n blobs. So we know this. Now we need to calculate the blobs. I'm not pretty sure about this, but like blob should be equal to, because it's like balls. So it's supposed to be. Can we use this form like this one?
It's the following. First, write it to the very end, and then we will discuss. It's the following. Since the rest will never give you the correct prefactors, writing this pi is relatively useless. Right, it's not a mistake, but it's an exaggeration of the accuracy. If you put there some prefactor dimensionless number c, or simply nothing, you write of the order of with this wavy line, then
okay. And there's another parameter like the end-to-end distance we could like maybe RF, the Florence radius. So it's supposed to be. So I can write in this way, right?
Yes, where RF is the Flory radius for the blob.
Yes. And so we can get this.
Wonderful.
And so let's compare the equation 1, equation 2, and 3. We can get the equals to the L3. So from this, this is the second equation we need, and the first equation A and equation B. So from these two, we can get the relationship between the. Sorry, I forgot to name check my notes. We need to get the. We need to find out the number of our blobs. So it's equal to. This one can be get n equal to L3. And m is equal to, from there, the m is this one. So we put this in there. We can get the form like n equal to L3, A3, H1, n 3v, and like 2. So with finally we can get this one like yeah, finally we get this one.
So these are brackets around, as far as I understand, yes?
Yeah. It's correct.
Let's put down the numbers. I know what has to happen then.
Okay. Okay, and because this is a cube, so it's obviously it's like 3 dimensions. So the v equal to d plus 2 like 3. So should be 0.6. So n is equal to a square n 1.8. Yeah, 3. 0. Like it should be like this. Yeah.
You better keep the so to say normal fractions up to the very end, because they are nicer to work with. You will see why.
Oh, okay, you mean to put this into there?
To put everything as a fraction, as fractions. 5,
Polymer.
Okay.
9/4, and so on.
Okay. Okay, so it's supposed to be fraction. Oh, and let's get inside there. So it should like. So it should be like this.
Yes. Now you see that it is a function of a divided by L.
Yeah.
Yes, and of the length of the polymer to the power of 9/4.
Yes.
Very good.
Okay, the final one, and we can check the units. Because this is equal to 1, so it's like n is proportional to n. A small n is equal to the capital N, so it's correct from in case of this. Okay, then the next step is we have to calculate the free energy, and as we know, free energy exit energy should be like the number of the total blobs equal to kBt.
Mm-hmm.
So we have n, so it's just go to L. So this is our excess free energy. Then we need to calculate the pressure which exists on the porous walls. So like the pressure should be the differential of the free energy divided by the volume.
Seriously, with minus in front.
Oh yeah. Yeah.
Good.
And so we need to figure out the value of what's the volume, and the volume is the cube apparently. So it's like this way. Correct? I'm not pretty sure about this.
Correct. What else? But you can...
Okay.
Mm-hmm.
So if we can write in this way, so like we just call this part like maybe H. So should I be H?
Mm-hmm.
Yeah, I think everyone can understand this step, right?
Correct.
Okay, so we can just like equal to H. So it's like
No. You know, delete this. Do it once correctly.
Oh, Yeah, sorry.
In the previous expression, volume
Yeah.
as it is.
Yeah, it's no, it's like
So it's
sorry.
minus h, yes.
Yeah, I need to one more step.
Correct.
Yeah, now it's correct.
Yes, and now your L cube is V. So it's dV to the power of, yes, minus 5/4.
Yeah.
And you get plus 5/4. And leave,
Yeah, should be like this one.
yes, and leave the volume, yes, minus 9/4. So now we can compare this with the expression, for example, which we got from the Flory-Huggins. Because if you put down H, put down,
Oh yes.
yes, right there
Okay.
H as it was. So put
Okay.
down C in normal units.
Let me write down. It's supposed to be this way.
Leave the volume as the volume was. Your L disturbs us.
Sorry, I didn't get this. What do you mean leave this volume
Now
alone or something?
look, my suggestion is the following.
Mm-hmm.
Now I would like to make a comparison between this result and what happens in the Flory-Huggins. I would like to see there something. I would like to see the concentration of the monomers. So if you put down a to the power of 15/4 as something like a volume per, or if you want, I know what we do. Try to form aus from
Okay.
A, N, and L.
I think yeah, you mean just combine these two?
Concentration, yes.
Yeah, like maybe I use another thing like maybe square, but this should be.
This I don't understand. What do you mean?
I mean because like this A and L should be both of them are meter. I mean the length.
Correct.
So if sorry, it should be like this way. So if we the plus to the minus 27, so it's supposed to be. So if we just talk about the dimension, so it's like the.
Talking about dimensions, it's correct.
Okay.
It's kBT, which has a unit of energy divided by volume. This is correct.
Yes, true. Like we can call it volume, yeah.
Yes. But I wanted somewhere else. If you want, we can discuss it afterwards. Let me have a look.
Oh, okay.
Let me have a look. Just let me put down this and have a look at the homework. What estimate the excess and the pressure. Now, okay. Wonderful. Now I come back to Zoom and I can tell you where I wanted to go.
Okay, yeah. So I stop my screen.
Stop your screen, yes, and I will open mine. Where is my pencil here? I must find my laptop again. Here, co-host. Once again. So what we got was the pressure P was equal, now you have to kBT, and then we had A to the power of what? I have forgotten. Tell me the numbers. 15/4 as far as I remember, N to the power of 9/4, L to the power of minus 9/4. Am I right?
L cube raised to, I think, 9/4.
The power of, yes, V. I will put the V. Yes, V to the power of 9/4. So essentially what I see here is a following structure. First, this guy is the concentration C to the power of 9/4 monomers per unit volume. And essentially, let me have a look what happens if I will try to put it in a following way. So if I have here, let me take it blue. I can put it as A cube to the power of 5/4. So what I will get here, and I can put it also in the following way. Let me think how to do it in the best way. I know how to do it in the best way. I will write it first via KBT. Now I will put it like A cube divided by V to the power of just a second. I'm thinking how to put it in the best way to discuss. Let me first leave here A and put here N 9/4, V 9/4, A 9/4, and here what will stay is A to the power of 6/4, which is 3/2. And now what I see here, and this 6/4 disturbs me. There is something which is still wrong. Are the powers correct with respect to what we did? Because I don't have the solution in front of my eyes. Can somebody tell me the power of A? I don't hear anything. Can somebody tell me the power of A?
I also didn't note down when Chi-Song was telling, but I think 15/4 was correct, I think.
Yeah, it's supposed to be correct.
So it was 15
15/4.
by 4. And then you have, I would like to take 9/4 to the outside, and I am left with 6 divided by 4, which I do not like. And I can tell you why I do not like this. This is because the dimension of pressure is force per surface, it is energy per volume, because force is energy divided by length. So it is kBt per volume, per unit volume. And somehow I do not get a correct dimension here. And the dimension was correct in the solution because we checked it. Now I have something here in the chat. I cannot speak to devices are too close, so okay, doesn't matter. So here I have some problems with some powers. Because P was minus dF over dV. F has a dimension of energy. This is our kBt, has a correct dimension. So the rest has to have the dimension of inverse volume. And here I have, okay, if I take this, this is volume to the power of 5/4, 9/4. No, here it's correct. So this means that I made a mistake somewhere else. So it's volume to the power of 5/4, volume 9/4, minus 4/4, minus volume. So this is correct. And now what I would like to do is to get here a to the power of 9/4 12. Now it's okay. Just a second. So what I would like to have here is the following. I will put here a cube to the power of 9/4, which is a to the power of 27/4. And I had here 15, which means a to the power of minus 12/4. Now it is correct. And now I will remove this. And I can tell you what I wanted to get. So this is a to the power of minus 3, has a correct dimension. P is kBt divided by a to the power of 3. This has a dimension of energy. And the rest is phi to the power of minus 9/4. Phi to the power of plus 9/4. Because phi is n a cube divided by v, is n divided by n0. And this we will also obtain in the next exercise, and this we can compare to the prediction of the Flory-Huygens theory in the semi-dilute regime. Okay, now let me stop this. Now at least I got it correctly. And let us now turn to the last, which is essentially a variant of the previous, but slightly different. Now, instead of having only one chain in a pore, I have many chains which hinder each other's motion. And here we want to express everything via phi. So who did this part of the work. Did anybody do it? Do I hear yes?
Yes.
Yes, yes, yes. If yes, then show us and then we will continue discussing.
Okay.
Great. Because whenever I can smoke, you know, I enjoy it. So, share your screen. You still must be a co-host. Yes.
Yeah, I can just squeeze you to the. Okay, I think this question is quite. Can you see my screen? No. Oh no.
Try it once again. Now we see something. We see it drawing, and now we see it.
Maybe I should rewrite it again.
Yes, you can simply write it parallel to showing us the solution. Yes.
Yeah, maybe I can explain my solution because I think this question is quite is not that hard. So
it is very similar to the previous one, but
yes.
After having it solved, I wanted to have a short discussion, and that's
okay.
the reason of having it there.
Okay, so let's begin like this. First we have to know what's the bulb size. So because it's a Florence ratio again, so we can get this formula. This is our blob size, and the monomer per site, the concentration of the monomer per site sigma is anyway, it's equal to this. It's like the monomer value in such bulb. So it's like this means the actual the exactly the monomer volume, and this is total volume. So we put this thing into there, so we get this, and then this is like, okay, we get this, and then finally we can get the relationship between the M and the I forgot how to say it. Yeah, we can get this. No problem, right?
So you assume here that the concentration of monomers with blob is equal to the total concentration of monomers in your system. Am I right? Do I interpret your statement correctly, or you meant something different?
No, I don't know. Just like I thought it in different way. I thought like this means in each blobs I'm talking about in, but actually it's supposed to be the same with the whole system.
This we can essentially show. But okay.
Sorry?
I say this we can essentially show, but you say that if we suppose that the concentration of blobs of monomers within a blob is equal to concentration of monomers in the whole system, because it's, so to say, homogeneous and fully filled by blobs.
Yes.
The size of the blob, the number of monomers per blob, is immediately connected with this dimensionless concentration, with phi.
Yeah, true.
Okay.
Yeah. So we get this equation.
Mhm.
So we go to the next step. It's asked to calculation the number of the blobs per chain.
Yes.
I think that's it. It's just this one.
Correct.
Yeah, because we have our small m. I mean the monomer per blobs. So we can get this one. So we go to the third step. We have to calculate the end-to-end distance r of chain.
Yeah.
So because like the in the equation, but in the equation it says at larger scales the blobs are it behaves like an ideal chain.
Yeah.
So as we know, ideal chains is supposed to be like this, yes.
Mhm.
So, but in this system, the end-to-end distance should be equal to the number of the number of blobs and multiply the square of the size of our blobs. So we get this equation, and we just simply put this into there. I mean, no, into there, and the n, and we can get the second one. Name check. No, we need this equation and this equation get in there, so we get this one.
Mhm.
And the second step, finally we get this one. And I think that's it. Oh no, sorry, it's wrong. There should be. And because the n equal to this one, so we put in there. So finally we get our this equation, which is the same with the in the equation.
Okay. So
yeah,
what
that's it.
when the phi grows, the size of the chain gets smaller.
Smaller. Yeah.
Yes, because the size of the block gets smaller. Now I
Yeah.
can tell you why I dislike all these 1.2 or 0.2. Because as educated physicist, I am used to write these, so to say, numbers if they appear with, for example, with two significant digits, or the second one with one significant digit. I always consider them as approximations with exactly as many significant digits. For example, 1.2 is everything between 1.15 and yes. And not that it is wrong, but this is
Yeah.
what how I understand these such numbers professionally.
Okay.
Wonderful. Now
Okay. So. Do you have anything to say?
yes, I see. I am absolutely unimportant. I hope that everybody else also can enjoy the solution.
Okay. I mean, so far the first three steps I think is okay now. Okay. If any question, just ask. I think. And then we go to the last one.
Okay.
And as we know the definition of the phi, we can know this one, like the phi multiply the total value, the total value of this whole system is equal to the volume of our polymer. So we get our first equation, and the second one, the number of blobs equal to the total
I don't
Sorry.
quite understand the first equation. What do you mean under V polymer? This is the total volume of all monomers. Or-
Yes.
Okay.
Yeah. I mean,
So it's the
it,
number of chains times the size of the chain times A cube.
yes, it's actually the same, but maybe your explantation is much better.
Okay.
But I hope everyone can understand this. So we go to second one. The number of blobs. It should be the whole volume of polymer. Is divided by the volume of per blobs. So as we know, this is the volume of per blobs.
Mhm.
This is the whole volume of our blobs. So we get this is our second equation. So as we know, the free energy should be equal to the number of blobs multiply the kBT. And so this thing is we talk about in there. Sorry, I didn't. So
I not quite understand your statement that the number of blobs is this V poly divided by Xi cube. This I do not understand.
it's like, okay, first way back to the first equation. The phi, like the phi multiply the whole volume should be like the volume of the, oh yes, it's like something. Let me check.
The total volume occupied by all monomers of all chains which are present in the system. This
Yes.
is how I understand one. If
Yeah.
I think about Xi, this is the size of the blob, and the blob inside
Yes.
empty, essentially.
So actually,
yes.
mhm.
So I
So
think
actually,
the number of blobs is the total volume of the vessel divided by Xi cube, because we say that the vessel is fully filled with these blobs.
oh yes, sorry, I mean, oh yeah, I forgot. Yeah, I was correct.
Mhm.
I mean, when I doing it, yeah. So it's supposed to be the total volume of system to
Total volume.
divide it by.
How I can understand it.
Yeah, sorry, I forgot how I did it. Yeah. So this first equation and second equation, and so we go to the free energy of the blobs. So it's like to kBT multiply the number of blobs. So it's this equation.
Okay, now I can.
And
Yes.
yes, and because we already know our the size of our, like, I mean, I think I don't need to. I mean, everyone can understand the second step, right? And so we use this equation again. Use this one again, so we can replace the n by phi. So we get this equation. Then we just get this. Okay.
Very nice.
Right.
But the next step is wrong.
Which step? This one?
This one is incorrect. The result is correct, but how to manipulate it is incorrect and would lead or could lead to errors in some other cases. Why?
I
Tell me, what is phi? Does phi by itself depend on the volume, or does it not?
So you mean the phi is also is varies is a variable of the volume?
The function of the volume. Because what
Yes.
is phi? Phi is the total number of monomers in your system, which means number of chains times number of monomers per chain, times A cubed divided by volume.
Mm-hmm. Okay.
And now put it there and do the rest correctly. The result will be the same. I mean, the functional dependence. But
Yeah.
it's always like this that you can allow yourself this mistake.
Okay.
Even when
Sorry, I'm not.
modifying the problem, I could formulate one in which these would lead to grave mistakes. So now what we have to do on this step, we have to first either the best thing here is, since we have to differentiate over the volume, we have to convert first phi into the volume and then to convert.
Okay, so
Just put down phi is equal just below this equation, which is correct. Phi is equal to, let's call the total number of monomers capital N mon.
1. Mm-hmm.
One, if you want. It's the number of chains times the degree of polymerization for each chain, times A cube,
Cube.
not square,
Yeah.
divided by V. And now you
Mm-hmm.
put it into your formula, and you will get a correct power of V there.
Okay, so really?
No, not equal to. No, not here. Dangerous.
You mean
Because you
there?
not here. In the previous formula.
Oliver, in
Yeah.
the free energy equation, KBT divided by A cube, phi raised to minus 9 by 4. There you need to substitute this volume so that this power and the nominator
Oh,
volume can give
there.
you downside highlighted.
You mean there?
Here.
Yes.
Because then you differentiate and you have here volume twice. In this special particular case, the result will be the same. But I guarantee
Okay.
that it's not always the same.
Okay, I got it. Yeah, true. So dirt F should be equal to the KBTV multiplied to the A3 and like this. Okay. So this should be
The powers of volume.
so if we do this again.
With minus in front.
Sorry.
It disturbs me automatically because I did so much thermodynamics in my life.
Yeah.
Yeah, it brings something, but yes.
Yeah, this is our final one.
Correct. So you get the same dependence, but this is essentially by chance. If you didn't have a power law function, but some different function of the volume, say logarithm or whatever, you will be in trouble. If you
Yeah, get it.
yes. Okay. And if we now restore all the powers, the result will be the same as for the single molecule in a pore. And now, this is what I wanted to comment on. So it is still, the pressure is proportional to something which is kBt divided by a cube, of the order of kBt divided by a cube, phi to the power of 9/4. And if we go to our last lecture last week, we would see that our situation here corresponds to a thermal solution. This means it corresponds to high equal to 0. We will see that at high equal to 0 at intermediate concentrations, we had phi squared. And this is the error of the Flory-Huggins in the semi-dilute regime. We get phi squared instead of phi 9 or phi minus 2 instead of phi to the power of minus 9/4. The power is wrong. It's not badly wrong, because it's wrong only by, how much is this? It's 1/8, essentially. 1 in 8, it's 12%. It's not too much, but still, you can see it, you can measure it. And this is the error the approximation gives for the osmotic pressure and essentially for whatever pressure in the system. And this is something I wanted to comment on. So here we see some deficiencies. And then you can try to correct for this, but whenever you try to correct successful and extremely simple theory, you get maybe something which is more successful, but extremely complicated. And here, you know, are there further questions? So if do we have to discuss something else with respect to this home assignment? Because if not, we can say goodbye to each other for today. I must tell you one important thing. And this is about, essentially, it's about next week. And just a second before I make an announcement, because otherwise I will forget and it will be not nice. Just a second, I have to open my mail folder. Just a second. So it's the following. Next Tuesday, in a week, exactly in a week, it will be 9th of February. I will have to chair a PhD defense, which starts at 9. And this means that I plan to be with you for the lecture on time. But if I will not succeed, because you cannot stop it, you cannot stop the procedure. And if it takes time, it takes time. I will be late, but I will give the lecture, whatever happens. I will be late maximally for quarter an hour. Just sit there, drink your coffee, talk to each other, and I will appear. And this is the only thing I wanted to tell you, because it might be that I will forget, and I don't have to. Okay, so Now, ladies and gentlemen, if there are no more questions, if there are no more wishes, then bye. See you tomorrow. Tomorrow is another day. Feel free. I feel free, but I'm essentially busy. Therefore, I'm also happy that we are finishing earlier today. Bye.
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 Bye.